Okay, so in this video, we're going to take a look at reflections, right? In particular, reflections across the X and the Y axes, right? So if we take a look at our graph here, and when we say reflection across the X axis, we say, all right, imagine like it was a mirror, right? So this will be reflected across, in one case, the X axis, and the other case we're going to look at is reflection across the Y axis, right? And how do we achieve that in terms of the function itself, right? So if we have some function f of x, right, and we want to reflect it across the y-axis, right? So if we look at what that would involve, it would say, all right, well, in this case, if I want to reflect it across the y-axis, if I wanted to show up on this side here, I would take all the, so notice that the y values would not change, right? So I still want the same y values, right? But what I want instead is for these x values, right, instead of 1 giving me 1, right, instead of having this here, instead of having 1, 1, right, I would like for that to show up over here, right? So here, let me actually, excuse me, 1, comma 1, right? If we just look at that point there, right, I would like for that to be reflected, right, across the y. So the corresponding value, right, in this case, we would have to switch, excuse me, the x, but I would still need the y to be the same, right? So that would be the point reflected across the y-axis, right, negative 1, 1. Okay, so as it turns out, in order to achieve that, right, if I still want the same output, right, the way that I do that in terms of my graph, it would have to look something like this. All right, so now here in this case, I take the negative value or the opposite value of my input, right, and that becomes my my output would be reflected across the y-axis. Okay, because as we see here, right, when we have negative 1, so if I have my f of x to be the square root of x, we get f of negative x. Okay, and the effect what that has in this case in the square root, right? It takes the negative here across, or the reflection across the y-axis, right? Where before that negative 1 wouldn't be defined, but if we take the opposite of the negative 1, then it gives me back to evaluating f of 1. Right, and overall that turns out to be a reflection across the x-axis. Excuse me, reflection across the y-axis. Now, for the other reflection, right, if this is reflection across the y-axis, reflection across the x-axis would take this point and it would reflect it across here. Right now, across the x-axis right here. So for this particular case, the x value would remain the same. And what would be reflected would be the y value, so the corresponding point here, so would be down here, right? That would be, and again, I just choose one point as an illustration, right? If we think of this curve as made up of an infinite number of points, all of these would have the same kind of effect, right? Where the x coordinate would remain the same, and then the y coordinate would just be the negative of whatever it is out here. Okay, so as it turns out, what I want is I want to evaluate the function same as before, but now whenever I get an output, I'll just take the negative of that output, right? So as it turns out, the reflection across the x-axis would look something like this, right? Where we just take the function as is, right? And then we just flip the y value across the x-axis by putting a negative in front of the function value, right? So this will correspond to reflection across the x-axis, right? And then we can see here, all right, if I do that, so take the negative there, And now here, let's get a different color to get a little more contrast. All right. Okay, and then we could see here now with the curve, right, by simply just taking the negative of all the outputs, we get a reflection across the x-axis. Right, so that's how we determine, or if we are tasked to reflect the graph across either the x or the y-axis, we would simply do it by a placement of the negative either inside of the argument before we evaluate it for reflection across the y-axis, or outside the function after evaluating for reflection across the x-axis.